So let's start with the pumping lemma for regular sets. That means the pumping lemma for regular languages. So the pumping lemma is a negativity test. Now what I mean by negativity test is through this pumping lemma we can prove that a language is not regular, but we cannot prove that a language is regular. It is a negativity test. The reverse is true. We can prove that the language is not regular. So the pumping lemma is used to prove that the language is not regular. Remember the Chomsky hierarchy. According to the Chomsky hierarchy, there were 4 types of grammars: regular grammars, context free grammars, context sensitive grammars, and unrestricted grammars, which each of them corresponded to the languages. The unrestricted grammars corresponded to recursively enumerable languages, the context sensitive grammar corresponded to context sensitive language, the context free grammar corresponded to context free language, and the regular grammars corresponded to regular languages. So the pumping lemma is used to prove that the language is not regular. Then if our pumping lemma, the test to prove that the language is not regular, is passed, that means if we have passed the pumping lemma test, that means the point 2 is true now. If the point 2 is true, then the language can be any one out of these 3 categories, because we have proved that the language is not regular. If it is not regular, then it can be either context free, it can be either context sensitive, it can be either recursively enumerable language. But if our test has failed, we have not passed the test, then we cannot say that the pumping lemma, by the pumping lemma, that the language is regular. What does this third point mean? If our test fails, then the language can be any of these, either regular language, context free, context sensitive, or recursively enumerable. Note this difference. If our test has passed, then the language can be either context free, context sensitive, or recursively enumerable. But if our test has failed, then we say that it can be any one language out of these 3. That means we are only able to prove that the language is not regular, but we are not able to prove that the language is regular. In the failing part of the test, we say that it can be any one out of the 4 categories. This is the pumping lemma. So let's discuss about the procedure, how to prove a language to be not regular using pumping lemma. So before going on to the actual procedure about how to test the non-regularity of a language by pumping lemma, consider one point first. The point is, we have to assume that the language L is a regular language. Any language that we want to test for non-regularity by pumping lemma, we will first assume that that language is a regular language. That means first we have assumed that it is a regular language, and after following the procedure of pumping lemma, we will say that we have contradicted our assumption and thus the language is not regular. This will be the procedure. So assume that L is a regular language, then it should have a pumping length P. What is this pumping length? I will tell you. First consider this point. It should have a pumping length P such that all the strings in the language L having length greater than or equal to that pumping length can be pumped. So what is the meaning of pumping length and the word pumped? Let's consider it now. Suppose L is a language of type 0n, 1n such that n should be greater than or equal to 1. Then this language can have strings like, if n is equal to 1, it will have string 0, 1. If n is equals to 2, it will have 0, 0, 1, 1. If n is equals to 3, it will have string 0, 0, 0, 1, 1, 1, and so on. It may carry forward. So these are the strings in this language L. Now it is saying it should have a pumping length P. Now let us decide P is equals to 4. This will also be an assumption. We have assumed the pumping length to be 4. This is also our assumption only. So if P is equals to 4, then the point is saying that all the strings in L having length greater than or equal to P. What are the strings in this language that are having length greater than or equal to P? That is 4. These strings. Leaving this string, all the strings after this string will have the length greater than or equal to 4. So according to our assumption, if L is a regular language and it is having a pumping length equal to 4, then all the strings in this language having length greater than or equal to 4 can be pumped. That means leaving this string, all the further strings can be pumped. Now what is the meaning of the word pumped? Consider this. If I take the string 0011, it can be pumped because its length is equal to 4. Condition is greater than or equal to. So it is equal to 4, it can be pumped. Now how to pump a string? See it very carefully. Divide the string into 3 parts. Suppose this 0 is x, this 0 is y, and these two ones fall in the part of z. We have divided the string into 3 parts. Now consider x, y, z as x, y, I, z, y raised to the power I, z, such that here I is equals to 1. Now if I increase the value of I by 1, if I make I is equals to 2, it will be x, y square z, or we can write it as x, y, y, z. Then the string will be x is 1 0, y is also 1 0, again y will be 1 0, and z are 2 ones. So after pumping, the string is 0 0 0 1 1. This is how we pump a string. We will loop the value of the middle part of the string, that is the y. We will not even touch x and z, we will only touch the middle part of the string, that is y, and loop it continuously. If I put I is equals to 3, then it will become x y cube z, or x y y y z. It will become x is 0, y is also 0 0 0, and z is 2 ones. So this is how we will pump the string. So our assumption is saying that L is a regular language and it should have a pumping length that we have decided to be equal to 4, such that all the strings in L having length greater than equal to 4. What are all the strings in length L? In language L having greater than equal to 4 pumping length, these are all the strings. These all strings can be pumped. So when we will follow the procedure of pumping lemma, we will prove this whole assumption to be wrong and then say that our language is not regular. We will prove that there is no pumping length p, and if there is some pumping length p, then the string is not be able to be pumped. So it is not following our assumption, and thus the language is not regular. So I am very excited to tell you the procedure and then test some examples. Come on, let's begin it. So these 6 steps include the whole procedure of testing the non-regularity of a language by pumping lemma. Step number 1 is note all the steps serial wise in your notebook. Step 1 is assume that the language is regular. Then step 2, assume some pumping length value. This was the point that I have discussed right now, that we have to assume the language to be regular and then we will decide some pumping length. And then in the step 3, all the string in the language which have the length greater than or equal to that pumping length p that we have decided in step number 2 can be pumped. We saw these 3 points previously. Now step 4 is consider a string satisfying these 3 conditions. The condition is the length of the string should be greater than or equal to the pumping length. We have to find out any string from the language that we are considering. Find out that string that is having length greater than or equal to pumping length from the language. Step 5 is we have to pump that string. I told you how to pump the string. Then after pumping, consider step number 6. Step number 6 says that show that the following 3 conditions never hold true at the same time. That means sometimes condition number 1 is false, other 2 are true. Condition number 2 is false and other 2 are true. Condition number 3 is false and 1 and 2 are true. So we have to show that these 3 conditions are never true at the same time, thereby contradicting our assumption that the language is regular and it is having some pumping length, or there are some strings in that language that have the length greater than or equal to the pumping length can be pumped. It is contradicting our assumptions, these 3 assumptions. Therefore the language is not regular. This is the procedure. Note these steps in your notebook. Then I am very excited to discuss the examples with you.